proof is fun. I think I got it completely wrong. I know I got it right.
That's the thing about proofs is you will know you got it right. I mean, it won't be a doubt that, oh, I think I got it. No, you know you got it right, or like, no, I didn't get it.
So I'm wrong. Yes.
All right. Any questions? Yes.
Number 12y.
12y?
Yeah, we have to solve for x and y.
Oh, okay. I thought you meant like it was an A, B, C, D, E, F, G, H.
Oh, yeah.
Wow. I gave you too much homework.
So the first 3 questions we had to draw triangles. The next time we had to solve out all these problems. The third type we had to.
All right. Sorry, Ben, you can't see what I'm drawing here. I'm drawing number 12. So you got this triangle. And then this piece extends down and goes across like that. And this piece goes straight across like that. And you're told that these two are parallel. And then you're told this is 110. Therefore, if that's 110, that's, that was your x, right, value. So we know that, I'm just going to write 110.
Dang it. I didn't see that.
Why?
Because I wasn't.
No, why? Reason?
Yes, because they're parallel.
Okay.
So they're the exact same side. They have to be the exact same
I
length.
want a name, though.
Parallel lines. No, a definition of
Because they're parallel lines, what are congruent?
the x's. The numbers. Corresponding angles.
Corresponding angles.
Why do I need to name all these proofs?
All right, so you know this is 40. Now I'm going to make you feel stupid, Anna. How big is this?
Oh.
40.
What?
70.
So how many of the interior angles do you know now?
2.
Therefore, the third one would be
40.
Is that right? No.
70, 60, 70, 79.
70, right? Where am I getting that from?
Right angle. 110.
Just look at the triangle. If you know 2, you can always figure out the third, just subtract from 180, right? So the 3 added up from 180, you know 2 of them, you can always figure out the third.
Hello.
So now I feel stupid for naming the 70 equals 1. Actually, I got that
No,
one.
that one's right.
Yeah, I got the second one.
What was the other one?
15.
15. I'm not gonna draw that. I'm gonna show you. Did I show this to you? Oh, it was Cadence I showed it to. Okay. All right. What do you see right there, right now?
That's the writing.
So this is 90, that's 40, that's got to be 90 and 40. That would leave, no, that one's 50. And then this one is part of that right triangle. If this is 90, that's 90, so can you figure out that one right there? No, but I do know that if this is 40, how did I do this? I did it so quickly last time. Oh, okay, so we said that this was how big? 50, 90, that would be 140, that would mean x is 40. So if x is 40, put a 40 there for me. Oh, we're done. What am I saying? That was the last one. Duh. Okay. All right. With that done, I'm going to just
Wait.
Ben, what?
Can you go over them all again?
I didn't go over any of them.
What? What were you going over then?
Individual people had an individual question, so I went over individually with them.
Oh, okay.
Number 10? 10 was the hardest one.
Yes, what was 10?
What's the hardest one?
Wait, were we supposed to use information from the previous question?
No.
No, you couldn't have because each one was an individual.
Right,
But I will say that I fully expected most of you to get 10 wrong. Here's, there
I
may
didn't
be
even say anything for 10. I didn't even know
there
what was
may be an
supposed to
easier way of doing it, but if you look at the picture, the interior angles are 6, 7, and 8. Well, if they're interior, that means they must add up to
180.
So I could write that as a statement. I could also say that there's linear pairs there. For instance, 11 and 8 are right next to each other. So 11 and 8 is 180.
180.
I could say 9 and 6 equals 180. I could say, what's the other one? 7 and 10. This is hard. So I'm going to individually do some substitution, one at a time. I'm going to set these two equal to each other. And then subtract the 8, and so what would I be left with?
6 and 7 equals 11.
So I get 6 and 7 equals 11. I'll do the same thing with these. Subtract off the 6, and we're left with
7 and 8 equals 9.
7 and 8 equals 9. And then this one and this one,
So then 6 and 8 equals 10. So then 9, 10, and 11.
6 and 8 equal what?
10.
Okay, so this says 9, 10, 11, right? So 9, 10, 11
So
equal what?
equal
2 6s
and
2
7s and 2
7s.
8s.
and 2 8s. But I already know what 6, 7, and 8 is.
180.
So it would be 2 times,
180, which is 360.
which is 360.
So all
Yes.
three-
Yes. There might be an easier way. I don't know, but that's what struck me as how to solve that. The book just says the answer is 360, but they don't give you a hint on how to do it. All right, so don't kick yourself if you didn't get 10. All right, I'm going to collect that.
Wait, you're not going over it?
Nope.
Oh, well, because of the pictures. Okay.
pictures on the main piece.
Well, I'm going to get to see your homework then when you attach it to the assignment, right?
Yes. I
Yeah.
guess I'll
Your
do
homework
that.
sounds really good today for some reason.
Me?
Audio usually sounds horrible, but today it sounds really good.
Me?
Yeah.
Oh, that's because I'm using a laptop and not my phone, which I've been using for the past few weeks.
Ah, now it makes sense.
Because my phone, like, whenever I say something, there's like a 3-second lag before I hear it on the other end of the audio.
Yeah, that's disturbing. All right, homework.
So if we have homework, we don't have to get it done until Tuesday at 6, right?
What? Tuesday at 6? Where are you getting that from?
Okay.
Well, if you think about it, we have the entire week and then Monday. Then you have to count, if we don't turn it in, you can count it as 50% off. So by Tuesday at 6:30 p.m.
Yeah, by Tuesday you can have an F. Agreed. That does work.
I mean, I guess you can turn it in on Tuesday. It's
And
probably
get an
gonna go
F.
well.
Well, you can pull a Haley and do that.
A who?
Haley.
Which
remember
Haley we talking about?
Davis.
Davis. She never turned in her homework, and when she did it, was like 3 days after it was due.
Do we have any other?
Well, there's a reason why Haley did not get a passing grade.
Yeah. Oh.
All right, here we go. Did I hand out the sheet or no?
No.
All right.
If we don't.
Hey, this whole class boils down to the last box. The
Oh,
last box has 4 different formulas.
oh, yeah. Oh, no.
So here is, I think, our first real true. We've had a couple others, you know, like segment addition postulate, angle bisector, segment midpoint theorem. Granted, we did get a formula from that one, but it's pretty easy. Here's your first formula that, you know, in some math classes they want you to memorize. All right, you don't need to write this down. We talked about a polygon being a closed plane figure. That means it's flat. It's on a plane. You can't get to the inside without crossing a line, and it's made up of segments that are joined at their endpoints. Poly means,
Many
and this is Greek, not Latin, and gon means
angles.
angles. So many angles are corners, right? A few rules that I haven't told you about, right? There's 3 of them. Well, actually, there's 4. No, 3 of them. 3 of them. 3 rules are, well, I told you about that one. All the sides are segments. They have to be segments. So polygon, yes or no?
Yes.
Okay. Polygon,
No.
we will get this shape. We call this a sector. I forget what chapter it is, chapter 11, 12, something like that. And we will calculate the area of that sucker too.
Well, that makes
And by the way, it's not a semicircle, right? This is a bit more than a semicircle. We'll be able to calculate for any circle a sector of it, but not a polygon. The segments must be joined at their endpoint. So polygon,
yes.
polygon.
No.
Why not?
Because it moves out.
Well,
They're not-
actually,
they ha-
no.
These have to be joined at their
No,
endpoints.
wait, that is a polygon. The bottom part is a polygon.
Yeah, but we're saying that this is the segment, not this. So if I strictly say the segment was right here, not a polygon. The last one is maybe new. The intersections that happen can only happen, the segments can only touch at their endpoints. So you could get, technically, from the first two, a shape that looks like this. Hey, all of my segments are joined at their endpoints. But I get this intersection because I made these two cross over. So I get an intersection that doesn't happen at an endpoint. That is not a polygon. Okay? So that was no. And I think you could have figured out that was no, and that was no, and that was no. All right, so there is one complicated rule. You do need to write this one down. This isn't a rule necessarily. These are both polygons.
So,
This shape right here, draw that, please.
in our book of truth,
Debatable.
okay.
I don't think I ever asked on a test this, so it's debatable whether it needs to be in book of truth. And then inside this shape, I want you to put 2 points. Anywhere you want. Just draw 2 points. So here's my 2 points. And then logically, I might want to connect the dots. Okay? So there's my first polygon, right? The blue one is a polygon, right? It's made up of segments joined at their endpoints. Nothing intersects other than at the endpoints. Here's another polygon. It's an L. Is it a polygon?
Yes.
Right? The
Yes.
segments all joined at their endpoints. This time I want you to draw the first dot right there. And the second dot right there.
So it can't connect at all because there's no way it.
Yes, it can. It connect.
They can certainly connect, but what's the difference?
One is completely inside of the polygon, and one is not.
So we have names for these two type of polygons. It's based upon the red dots and the line segments. The first one is called a convex polygon. And that's where any 2 points
Concave.
No, first one is convex.
No, the second one is concave. I know this.
All right, thank you. First one's convex. So if you draw any 2 points on the inside, when you connect those 2 points, you will never intersect the side of the polygon. And then the second one is Ben stole my thunder.
You're
Right.
welcome.
Thank you. All right. It's not saying that all points drawn, but you are able to draw at least 2 points where when you play connect the dots, they do intersect the sides. So that's the difference between convex, concave. For the most part, we will primarily in our geometry concentrate on convex polygons. We will have some problems that do have concave. Interestingly enough, we don't get many rules for concave polygons. We get lots of rules for convex polygons. In fact, you're going to get 4 formulas today about convex polygons. Oh, by the way, you can always turn a concave polygon
Into a
with a pair of
convex.
scissors into a convex just by cutting that off right there. And then you get 2 convex polygons. Which is why we don't need rules for concave polygons. What is so funny? Okay. All right, we good?
Yes.
All right. So if you need to write this down in your book of truth, you need to write it down. If you don't need to write it down. I'm going to tell you number of sides and the name. Okay? So the first polygon we have is
Triangle.
how many
Triangle.
sides?
3.
4.
Quadrilateral.
Quad meaning 4. Lateral means sides. 4 sides. Next.
Pentagon. 5.
Why do they choose Greek over Latin or Latin over Greek? I have no idea. Somebody made that decision a long time ago.
Because Greek is superior to Latin.
Yeah, but some of these will be Latin, some of these will be Greek. It's like they pick and choose. Right? 6 is
Septagon.
This needs to go into your-
Hexagon.
It says all of you said the wrong thing until the last person said hexagon.
It's me. I said hexagon.
Yeah, but you first said septagon.
No, I didn't.
7 sides. That's a septagon.
Now, our book chooses another word for 7 than septa.
What?
There's another word for it, and it's called hepta.
Heptagon.
So heptagon is, now that's our book There's other books that use septagon as well too. But if I have it on a quiz or test, I'm going to use heptagon. 8 is,
An octagon.
no, it's stop sign.
8 octagon.
Octagon.
Yes, it is octagon. 9 is equally forgettable.
It's a nice.
Nonagon.
Ben, are you looking in your book?
No, I know all 12, the 1 through 12 by heart.
You're
Okay.
amazing, Ben.
10
You
is,
should recite them.
10,
Yeah.
10 is,
10. Oh, number 10.
yes.
Oh God. Do it.
You just said you knew all 12.
I thought I did. Isn't it a?
How many years if you go 10 years?
Well, it's a decagon.
All right.
Oh my gosh.
Now, any polygon can have another name.
Oh no.
So if I don't want to specify how many sides, and I just want to talk about a polygon of an unknown number of sides, we assign a variable, and that variable is n for the number of sides. So we call any polygon also, if it
A
has
polygon.
n sides,
11.
we call it literally an n-gon.
End go.
Yes, and you will see this plenty of times in our book.
Darn you.
It says you have an n-gon. It just means you have a polygon of unknown number of sides. Typically, you're solving for n.
Well, I know what n is.
Tonight
It's
for
not
homework or over the weekend, you'll be solving for an n-gon.
Well, I know how you solve an n-gon. All you gotta do is count up the sides and boom.
What if I don't give you a picture?
If you don't give, well, how do you have to give me a
No,
picture?
you don't.
No, I'm going to tell
No,
you.
you
the
don't.
n- You're going to tell me how many sides.
But how do I know it's I don't
Because
know.
you're going to have 4 formulas to use tonight. Okay, here we go. Quick recall. Remember, we name any polygon by
3 points.
no all points.
A, B, B, C.
So
See,
for
then
this
you
one,
put, like,
you
11
name
points in
the first. You name the polygon. What is it?
A,
A, B, D, C.
No, name the polygon.
Quadrilateral.
This is quadrilateral. Then you give it specific name.
A, B, C.
Pick any letter and go either clockwise or counter. You got to stay on black line, and you can't skip anything. So this is quadrilateral, either A, B, C, D. There's lots of these. There's 8 different ones
B,
here.
C, D.
Or you could start with, I don't know, C and go counterclockwise. C, B, A, B. Okay. C bad.
See that?
Yeah.
See that?
All right.
See that?
If you want, calculators might be helpful right now.
Yes.
Wait, why do we have Jack's calculator? Why not the?
No, this is my calculator.
Oh,
You
Jack
stole
now has a
Jack's.
case, and his doesn't look like it.
I can take it off and I'll look at that
All right.
one here.
All right, so think about this. Yes.
Where's my locker during
Yeah, it's not that important. I'm going to ask for some answers quickly, and just somebody's got to use that. Okay. If you connect any corner of a polygon to any non-adjacent corner, you make this shape.
Triangle.
Well, I mean the red line.
a line.
Guess what we're going to call that red line?
A line. Red line. Intersector.
If this was not math class, you'd call this a,
Transversal.
you'd call it a,
Intersector.
in regular life, you would call this,
It's a line.
you would call it a diagonal line.
No, you just call it a line.
So-
look at-
In math, we call that a diagonal. A diagonal is what connects any vertex of a polygon to any non-adjacent vertex.
Oh, look, a diagonal. Oh, look, a line.
Well, you would say that's a diagonal line, yes?
no, I wouldn't. I would say
Depending
that's
on
a
what,
line.
but depending if I shift my head to the right, then it would be a horizontal line.
Okay, true.
Or if I shift my head this
All
way,
right.
it would be a vertical.
Diagonals in our book are generally, I haven't seen one that is not, maybe there is one, are generally outlined in red. It's an auxiliary line, right? It doesn't really exist in the polygon. Okay, so it turns out that here are just 3 polygons at random. It turns out that you can break any polygon into triangles if you make a diagonal.
Yep.
So if I make a diagonal, now I have 2 triangles that make up that one shape.
So you get 3 triangles from the next shape.
Okay. And then on this one,
Or
you get 4. Let's see if there's some pattern we can recognize. First off, what's the name of the shape?
Quadrilateral.
How many sides?
4,
And how many triangles did we just make?
2.
Now you could make more. We could put the other diagonal and get 4, but we're going to say the least amount of triangles. Okay. How many sides?
5.
How many triangles?
5 side.
3.
2, 3, 4, something.
How many sides?
6.
And how many?
4 triangles.
Okay, do you see a pattern?
Yes.
What's the pattern?
Again,
Uh,
gradually goes
6,
up.
2, 3, 4.
The number
Any other
It's the
pattern?
number of sides minus 2. Well, that's how many triangles you get to make.
The number of sides minus 2 tells you how many triangles.
Aha.
You
So
see that?
What if,
Okay.
what if the side of the triangle is like 6,000?
Then it would be 6,000 minus 2.
But what's 6,000 minus 2?
5,998.
That n gone, where n is equal to 6,000.
But how do you draw
All right. Recall that the sum of the interior angles, this is theorem 311, the sum of the interior angles of triangles is 180 degrees. So if I now ask you, what is the sum of all of the angles?
180.
Well, how many triangles do you have?
2.
So it's 2 times,
180.
which is,
360.
well, that one's got to be 360. There's 3 triangles, so it'd be 3 times,
180.
which is,
Some number.
why do you have a calculator in front of you?
Okay, 1 second.
540.
You're supposed to be the smart class to figure that out.
720.
All right, you see how we did that? So what's the formula I just used to find the sum of the interior angles of a polygon?
180 times the number of triangles.
What's the formula I used?
190.
You gave me words. I want a formula.
180
Numbers.
Times 2. 1 times 2.
180 times 2 equals, no, 180 times n of triangles.
It's not n of triangles. What does n represent?
The number of sides.
Number of sides.
So 2 times.
You guys are tap dancing all around the answer. How,
Two
how did we
n.
get that number right there?
It's a number.
How did we get this number?
4 times
Oh.
180.
How did we get 4?
N
n minus 2, where n represents the number of sides, minus 2, and then
times
Times 180.
that's the formula. This is theorem 313. You just proved it. N minus 2 times 180. If I gave you a polygon, and I say, you got to be careful here, I say the sum of all the interior angles, you just plug in n minus 2 times 180, where n represents the number of sides of the polygon. I can't help it.
So now I'm a math genius.
So here is the first honest-to-God formula this year that you hopefully, I mean, I will say this is a memorable one for me. I don't know why this one stuck with me. I've always remembered this one. You know, you remember the quadratic formula, you remember the Pythagorean theorem, and then this one I remembered as well too. But some of the other ones you will not remember.
I basically forgot all theorems, so I need help.
That's why you have a book of truth, so that you don't have to memorize it. Okay, that's theorem 313. We good?
Wait. No.
N minus 2 times 180. And no one's going to remember it's 313. You're just going to say the sum of the interior angles is n minus 2 times 180.
Or can I just do n times 2 equals 120?
N times 2 equals 120 is not true.
Yes, it is. N times 20.
All right, so what's the shape? Well, this is an example.
Pentagon.
Pentagon, so what's the sum of the interior angles?
540. 540.
How'd you get that?
Because of previous slide.
N minus 2, where n is 5. 5 minus 2 is 3, and 3 times 180 is 540. Okay. Another one, next skill. We just did interior angles. We're going to calculate the sum of the interior angles. So this is your bad slide. The first skill I just showed you was that. You can now calculate all of the angles added together of a polygon that are on the inside. That begs the question, what? We just added up all the interior angles. What's question would be the natural next question? How do you add up the exterior angles? All right. By the way, one more practice.
What's it? 720.
How'd you do that?
N minus 6 minus 2 times 180.
Okay, so 4 times 180 basically, right? Okay. So the natural question is, well, what about the external angles? Last class we made external angles. How do we make external angles? We add an auxiliary line. So we shall, here's 3 examples. All right, same 3. I'm going to make the exterior angles of that one. See what I did? Those are all the exterior angles.
Those all add up to 360.
Well, let's see if that seems to be a reasonable answer. So if I start with this lower left one, I'm starting right here. If this was a protractor, I measured I'd be measuring from here to here, right?
It's 90 degrees.
So I'm going to turn this until I measure. Oh, I measured. Oh, now I'm right here. So I'd measure that to there. Oh, now I'm right here. I measure that to there. Oh, I'm right here. And what happened to my stick?
You just made a circle.
I made a full circle. So intuitively, we think it's 360. This isn't a proof, by the way. This is me flipping a stick
And
around.
it is 360.
Right. Well, I'm just saying, intuitively, it seems like it should be 360. This is not a proof. This is just us thinking it sounds like it should be true.
Well, I mean, it is a proof because all of them are 90 degrees.
Well, there's no 90 degrees here.
No, on the quadrilateral.
Okay, so you proved it for a quadrilateral.
Okay.
What about for a pentagon?
Um,
And what about for a 471-sided figure?
I think it's just the same formula as the last one.
Well, it's not the same formula as last
No, it's
time.
not, 'cause the
So,
last one was 8.
Let's see if we can solve this. And it's
They're all
pretty,
360.
it looks like they're all 360. But let's see if we can prove it. I'm going to prove it to you algebraically, like we're going to do some algebra. Let's look at one
That is a mess.
angle right here, lower right. I have an internal angle and I have an external angle. Yes? What do you notice about both internal and external
They're
angles?
supplementary.
They're supplementary. They make a straight line. They're a linear pair.
So they're just supplementary.
Okay, let me. So the sum of one interior, this one, plus the sum of this one must be
180.
180. We good?
Uh-huh.
Well, what would be
They're
the
not
sum of?
95.
What would be the sum of all of the interior angles plus the sum of all the exterior angles?
180 times 5.
Okay.
No,
Well,
180.
it would be 180 times how many?
The number of sides.
Number of-
180
Not
times
sides, but number of angles, and that would be the same as the number of sides, though, right? So we could say n, right?
Yeah, so 180 times n.
Do we have a formula for this? The first green?
Maybe.
You just wrote it down. N minus 2 times 180. I don't know. I mean, okay, granted, it is 360, but I'm saying we haven't proven it yet. So I got to put a variable. We'll just call it x. Yes, it ends up being 360. But I'm saying I don't know it until I prove it. And I do know that, oh, this is 180 times. And look at the magic here. Hey, distributive property, do it.
180 n minus 360.
Hey,
And then-
look, I got a 180 in on both sides, so guess what happens?
360 plus so x equals 360.
Poof, it goes away. Subtract 180 n from both sides, so therefore x is equal to,
360.
well, now I really proved it. So we can write that one down. But did I start with a pentagon or did I start with any polygon?
Any polygon.
So this is true for any polygon. It's just one number. Remember, interior angles is going to change because n minus 2 times 180. This never changes, right? This is theorem 314, all right? It says that if you add up the exterior angles of any polygon, it's always 360. So I said 4 formulas. This isn't really a formula. It's a fact. But I will call it a formula for now. So this is our second one. And this is confusing. And it's confusing because it's got the word interior and exterior between those two formulas. You know one is 360. Generally, we tend, if we're not thinking it through, we think it's the inside that's 360. Because you can almost see the circle on the inside, right? So if you're going to mess this up, it's going to be because I'll ask for interior, you'll give me exterior, or vice versa. So make sure you read the question carefully, and you have on your, your book of truth, in nice bold letters, it says interior, exterior. Okay. So the new skill is, well, you can calculate the exterior angles. What's the sum of any polygon its exterior angles?
180. No, wait, not 180.
It's literally what you just wrote down.
Oh yes, it's 360.
It doesn't matter what shape. The answer is always 360. Okay? So 2 skills so far. The sum of the interiors is what?
Is n minus 2 times 180.
And the sum of the exterior?
Is 360.
Okay, and I said we've got 4, so there must be 2 left. The other 2 come from these 2 formulas. They're going to be different formulas, but they come from these 2. All right. I'm going to just show you this really quickly. I don't think you need to write it down. If you have a polygon where all the sides have the same measurement, guess what we call it?
A polygon.
If all the sides are the same measure, guess what we're going to call it?
Right. Yeah, it's a culinary. No, not culinary.
What do we call a triangle where all the sides are the same?
It starts with a C.
So what are we going to call a polygon where all the sides are the same?
Equilateral polygon.
And that's what that is. Okay? What do we call a polygon where all the angles are the same?
Equiangular.
Now, what do we call, you won't know this one, what do we call one that is both?
Equal angular lateral.
Yeah, it's a weird name. I would have called it the perfect polygon because all the sides are the same and all the angles are the same. They don't call it perfect, they call it a regular. Of the three, this is the one I want you to write down. A regular polygon is one where all the sides are the same and all the angles for the same. Now, I didn't listen to Ms. Shankly when I took high school geometry, and what I heard was everything is the same, so I literally thought that the angle measurements and the side measurements were the same. And Ms. Shankly said, yes, that's true, but what I didn't understand was, what she meant was the sides could all be 5, and the angles could all be 20 degrees. All the angles, this is a better picture here, all the angles here are 120. All the sides, well, it's not listed, but they're certainly not 120.
They might be.
Millimeters, maybe, right?
I mean, it doesn't matter. I mean, that could be anything.
They could be anything, right? But like I said, what I heard was everything was the same, and so I literally thought the sides were the same as the angles, and that's not what we're saying here.
But it's true.
It could be true. You could have a side measurement of 10 and an angle measurement of 10 degrees. That could happen. But we're not saying that's in every single case.
Well, then for a regular polygon or an equiangular polygon, there is a certain number.
Oh yeah, that's
for
true.
them.
That's
So, just like this one is an octagon.
yeah. If I scale this up so the side measurement is 120 inches, then okay, then the numbers do match.
Well, I mean, the angles all have to be the same, so there's 120.
Yeah, but it doesn't mean that the side length is 120.
No, that's not what I'm saying.
And that's what I thought I heard her saying.
But I'm just saying that all of the angles have to be, for example, in this example, 120.
That's right.
It's because it's equal.
Because it's equiangular.
And also, it can be 120.
Sure it can.
So then it has a certain number for each thing. Because it's
For
equiangular.
each regular polygon, it absolutely has a special number for angle measurement, but not for side
Or
measurements.
equal angle.
No, that's all I'm saying is equiangular,
Right.
but not for equilateral. They could be any measurement.
That's
All right. So we got to get to the last two. We got 4 minutes to do this. All right. So it says challenging. It's not that challenging. This only applies to regular polygons. All right. So the first one is, okay, here's a new one. Hey, I got a pentagon. What's the sum of the interior angles?
540.
Okay, so it's 5 minus 2, 3 times 180. Okay. So we get 540. What's the sum of the external angles or exterior angles?
360.
Always 360. Okay, that's what we've done so far. Here come the two new formulas. How much is one of these angles?
It's an angle.
How much is one?
180 divided by 5.
So you take, no,
340.
no, you said
540.
340.
540 divided by 5.
540.
You take the answer, you divide it by the number of sides. So we actually do get another formula.
So it's 180.
We take the original formula, and then we take the whole thing and we, what did you do to get to your answer?
Divided by
Number of sides, which in this case is the letter
n.
n. So it's n minus 2 times 180 over n is the formula. So if I say, what is the value of an internal angle? Or a internal angle of a regular, it's got to be regular. It doesn't work if it's not regular, right? You just simply take this formula, divide it by n. So I take 540 divided by n is 5, and
108.
I get 108. Guess what the next question will be?
What is the exterior?
What is one exterior angle?
Which
And
varies. Which varies.
so what am I going to do?
You
How much are all of them?
360 divided by 5.
So it's just 360 divided by n, in this case divided by 5. Okay, we get 72. So bell's about to ring. Let's write down these two formulas. Let me get to them. All right, so sum of the interior angles, n minus 2 times 180. Sum of the exterior,
Well, 360.
sum of one interior angle. This should say polygon, not hexagon.
Some of it.
There's the formula.
Attention students
And
and
what's the
teachers,
sum of
this lesson is
one
about to begin.
exterior
Happy
angle?
Friday, everyone.
360 divided
At
by
this
n.
time, please dismiss all walkers, bike
I do
riders,
want to
and
show you one more
trolley
thing.
Please hold staff
Do you
kids and
see,
YMCA
we got all
until
those copied
dismissed.
down?
Thank you.
The table, look at the table. In class exercises and in homework, it's blue. I'm going to skip to it. Right here, you see it? I always get questions on this, so I want to show you. Hey, if I tell you the number of sides, could you find the measure of each? That means one internal and one external. Could you do that?
Yeah.
That's easy. Look what happens here. What are they telling me? That one external angle equals 10. So what was the formula I just gave you for the measurement of one external angle?
360.
So I do 360
36 angles.
divided by n, and we're told that that equals, solve that, and you find out n. Then you can find out the other one. On this one, what are they telling me?
You have to find out n into.
This one's a bit ugly, right?
So
Well, it says one internal angle. Well, I know the formula. What's the formula for internal angles?
n minus 2 times 180 over n.
And we're told that that equals, well, let's do an easy one, 90. So how would I actually solve it?
You just input.
How would I actually solve it?
You would multiply by n. And
Multiply both sides by n, so we get n minus 2 times 180 is equal to 90n.
And then you subtract. Oh, and then you do the
Distributive property, move things around, solve
And then
it.
you get 90n equals 180, and then you get n equals 2.
Okay, so we get two sides. You can't get two sides. There's no polygon with two sides.
Why not?
What polygon has two sides?
Oh no, it's 4. Sorry.
Okay.
It's 4. I didn't do the subtraction.
All right. So it's quadrilateral. Right.
Yes.
Ben, do you have any questions?
No, I do not.
You couldn't see what I just did, so you might have some challenges on the table.
Oh gosh. You
But
can always
what
just
I
take a
was
picture.
Please now listen to the numbers for Carline.
Let me point the screen, and I'll let you take a picture.
Okay.
290 Morris, 136 Conquest, 230 Dauber, 114 Suffolk.
This is kind of messy, but that's what I did. Can you see that?
106 Berg,
Your screen's frozen.
312 Beck,
Is it still frozen?
204 Gasper, and 216.
Yeah, it's frozen. Your audio is breaking up.
How about now?
Oh,
How
yes.
about now, Ben? So that first one there on the left, that's where if they give you an external angle, one of them, set it equal to the value that they give and then solve for n. That second one, n minus 2 times 180 over n equals whatever they give you for a value. I solved it there for 90, and that's how you solve it for n.
Can you repeat that? Your audio's still glitching up.
Yeah. So the second part of the table, it gives you one internal angle right here, 90. So all you do is you go to the internal angle formula, n minus 2 times 180 divided by n, let it be equal 90, and then solve that equation for n. I'll erase this. Multiply both sides by n, and then solve for n. Make sense?
Okay. I'll try figuring it out.
Okay, if not, send me something, even if it's over the weekend, so if you needed like a quick, 2-minute Zoom thing, I could show you how to do it.
200 Bailey,
Okay.
161
Okay, hey, have a good weekend, Ben.
130 Hoffman,
Bye.